floating islands in the oceans and how they exist. The concept of floating islands in the oceans has long fascinated scientists, environmentalists, and dreamers alike. These unique natural formations or artificial constructs represent a fascinating intersection between geology, biology, and human ingenuity. In this article, we will explore what floating islands are, how they form naturally, their ecological significance, as well as human efforts to create artificial floating islands for various purposes. What are floating islands? Floating islands can be defined as masses of vegetation, soil, or other organic materials that float on the surface of water bodies, including oceans, lakes, and rivers. These islands are not fixed to the seabed but instead drift with currents, winds, and tides. While most commonly associated with freshwater environments like ponds and marshes, floating islands also exist in marine settings, though they are rarer due to the challenges posed by saltwater and wave action. There are two main types of floating islands: natural floating islands, formed through natural processes involving plant growth, sediment accumulation, and erosion; artificial floating islands, constructed by humans using modern technology and materials for specific purposes such as habitat restoration, agriculture, or urban development. How natural floating islands form. 1. Vegetation growth. One of the primary mechanisms behind the formation of natural floating islands is the growth of aquatic plants. Certain species, such as water hyacinths, reeds, and cattails, have root systems capable of trapping debris, sediments, and dead plant matter. Over time, these trapped materials accumulate into a thick mat of organic material that becomes buoyant enough to float on the water's surface. For example, in freshwater ecosystems, submerged plants like Eucornia crassipes, commonly known as water hyacinth, grow rapidly and spread across large areas. Their extensive root systems collect detritus and nutrients from the water column, eventually forming dense mats that detach from the bottom and become free-floating. 2. Sediment accumulation. In addition to vegetation, sediment plays a crucial role in the formation of floating islands. Rivers carrying silt and clay particles deposit these materials in slow-moving waters where they settle onto decaying plant matter. As more sediment accumulates, it adds mass to the structure while maintaining its buoyancy through trapped air pockets within the organic matrix. This process is particularly evident in delta regions where rivers meet the sea. The Mississippi River Delta, for instance, contains numerous floating islands composed of mud, sand, and organic debris carried downstream over centuries. 3. Erosion and detachment. Another way floating islands form is through erosion. Shorelines made up of soft soils or loose sediments may erode during storms or high tides, causing chunks of land to break off and float away. These fragments often carry vegetation with them, which helps stabilize the island and promotes further growth. In coastal areas affected by rising sea levels or extreme weather events, erosion-induced floating islands could become increasingly common. However, their survival depends on several factors, including water depth, wave intensity, and availability of nutrients. Ecological significance of floating islands. Floating islands play an important role in maintaining healthy ecosystems both in freshwater and marine environments. Here are some key ecological benefits. 1. Biodiversity hotspots. Floating islands serve as habitats for a wide range of flora and fauna. Birds, insects, amphibians, and even small mammals use these islands as resting places, breeding grounds, or refuges from predators. Additionally, many aquatic species rely on the roots and stems of floating vegetation for food and shelter. For example, in Lake Titicaca in South America, indigenous communities have built artificial floating islands called Euros using totara reeds. These islands not only support human life but also provide homes for native birds and fish. 2. Water purification. Plants growing on floating islands help filter pollutants and excess nutrients from the water. Through processes like phytoremediation, they absorb harmful substances such as nitrogen, phosphorus, and heavy metals, improving water quality and reducing the risk of algal blooms. In polluted waterways, Introducing floating islands can significantly enhance ecosystem health by restoring balance to nutrient cycles and promoting biodiversity. 3. Carbon sequestration. Like terrestrial forests, floating islands act as carbon sinks, absorbing CO from the atmosphere through photosynthesis. When plants die and decompose, their carbon-rich remains contribute to the organic layer of the island, effectively locking away carbon for extended periods. This makes floating islands valuable tools in combating climate change, especially in regions prone to flooding or coastal erosion. Challenges faced by natural floating islands. Despite their numerous advantages, natural floating islands face several threats that jeopardize their existence. 1. Human activity. Pollution, deforestation, and agricultural runoff introduce toxins and excessive nutrients into water systems, disrupting the delicate balance required for floating islands to thrive. Invasive species introduced by humans can outcompete native plants, leading to the degradation of existing islands. 2. Climate change. Rising global temperatures and changing precipitation patterns affect water levels, salinity, and temperature regimes in ways that challenge the survival of floating islands. Increased storm frequency and intensity can physically destroy islands or push them far from their original locations. 3. Fragmentation. As water bodies shrink due to droughts or dam construction, floating islands may fragment into smaller pieces, reducing their ability to support diverse life forms. This fragmentation also limits their potential for providing ecosystem services. Artificial floating islands, a solution to modern problems. To address the challenges facing natural floating islands and to harness their benefits, humans have developed technologies for creating artificial floating islands. These structures mimic the functions of their natural counterparts while offering greater control over design and placement. 1. Materials used. Artificial floating islands typically consist of a buoyant base made from recycled plastics, foam, or other lightweight materials. On top of this base, layers of soil, mulch, and vegetation are added to create a stable platform for plant growth. Some designs incorporate solar panels, wind turbines, or rainwater collection systems to make the islands self-sustaining. 2. Applications. The uses of artificial floating islands are varied and innovative. Habitat restoration. Reintroducing native plants to degraded water bodies enhances biodiversity and supports wildlife populations. Urban development. Cities facing space constraints can build floating parks, gardens, or even residential complexes on water. Agriculture. Aquaponics systems integrated into floating islands allow farmers to grow crops without relying on arable land. Disaster relief. Temporary shelters constructed on floating platforms can house refugees displaced by floods or tsunamis. Examples of successful projects include the Floating Farm in Rotterdam, Netherlands, which produces dairy products sustainably, and the Biohaven, a registered floating islands used worldwide for water treatment and habitat creation. Technological innovations in artificial floating islands. Recent advancements in engineering and materials science have expanded the possibilities for designing and deploying artificial floating islands. Key innovations include: 1. Smart sensors. Equipping floating islands with sensors allows real-time monitoring of water quality, weather conditions, and structural integrity. This data can inform maintenance schedules and optimize performance. 2. Renewable energy integration. Solar panels and tidal generators installed on floating islands generate clean energy that powers nearby communities or supports onboard systems. 3. Modular designs. Modular construction techniques enable easy assembly, disassembly, and relocation of floating islands, making them adaptable to different environments and needs. 4. Biodegradable materials. Research into biodegradable alternatives to traditional plastics aims to reduce the environmental impact of artificial floating islands while preserving their functionality. Environmental concerns surrounding artificial floating islands. While artificial floating islands offer promising solutions to many pressing issues, their deployment must be carefully managed to avoid unintended consequences. Potential risks include disruption of local ecosystems, Introducing foreign materials or plants could harm native species or alter natural processes. Waste management. Ensuring proper disposal of worn-out components is essential to prevent pollution. Cost implications. Building and maintaining large-scale floating islands can be expensive, limiting access for developing countries or rural areas. Conclusion. Floating islands, whether natural or artificial, represent a remarkable phenomenon that highlights the resilience and adaptability of nature. From supporting rich biodiversity to mitigating the effects of climate change, these dynamic structures play vital roles in sustaining healthy ecosystems. By combining scientific understanding with technological innovation, humanity can unlock new possibilities for utilizing floating islands to address global challenges such as food security, urbanization, and environmental conservation. As we continue exploring ways to coexist harmoniously with our planet, floating islands stand as a testament to the power of collaboration between nature and human creativity. Whether drifting freely in remote corners of the ocean or engineered to serve specific purposes, these islands remind us of the beauty and complexity of life on Earth. This exploration into the world of floating islands reveals just how integral they are to both natural systems and future-forward thinking. With ongoing research and development, there's no doubt that floating islands will remain at the forefront of discussions about sustainable living and ecological preservation.